In this second video of differentiation, we're going to talk about parametric equations, and we will do a quick revision on what parametric equation actually is in the first place, okay? So let's take a look at this question, and we will revise along the way. The curve C has parametric equations x equals to 2 plus 2 cosine t, and y equals to tangent t for t is between 0 to pi over 2. Okay, so a quick revision on what parametric equation is, instead of writing an equation in Cartesian form. For example, y equals to 2x plus 1. When we first learned this in secondary 2, what we did was we have an equation linking up values that satisfies this equation, and we plot it onto a graph, right? What I'm trying to say is this: for every x value, the equation will give you a particular y value for that x value. So for example, if x is 0, y will give you 1, right? So this point known as 0, 1 satisfies this equation. 0, 1 satisfies this equation. Now for another point, for example, if x is 1, y would be 3, right? 1, 3 also satisfies this equation. What that means is if you go to the graph, 0, 1 is here, 1, 3, it's 0, 1 is here, 1, 3 is here. These are 2 points that satisfies this equation. Now you can actually go and find a lot more points other than these two, right? You find out that this point will work, this point will work, this point will work, and eventually, once you have plot enough points, all these points will sort of connect together to form a straight line. Remember how we get these points? From a particular x value, we get a y value, and vice versa. We can also come up with a y value, for example 5, we can come up with a x value 2. So it's linked directly between x and y. What a parametric equation is instead of using an x value to find a particular y value, or using a y value to find a particular x value, we use a middleman, inverted commas, middleman, to find out points that actually belong on this graph. So for example, x equals to 2 plus 2 cos t, and y equals to tangent t, right? In this question, instead of me churning out x and y value, that means like I put a 0 here, I find out what is y, or I find out this 1, what is this value, we are going to make use of an additional middleman known as t. Now we will be moving t. T can be 0, it can be 0.5, it can be 0.75, whatever t can be. It will be denoted here. T will be values between 0 to pi over 2. Now using these values, I'm going to generate out that particular x and y coordinates. So for example here, when t is 0, x will be 2 plus 2 cosine 0, which gives us 4. What about y? Tangent 0 will give us 0. So when t is equal to 0, 4, 0, this point known as 4, 0 will appear on our graph. You would not be able to see t. T is sort of invisible, right? This t is invisible on our xy graph, but you will see 4, 0 here. This particular point, 4, 0. This is when t is equal to 0, and so on. You can generate way more points. Now you can use a calculator to help you do that. Later we'll take a look at how it actually generates this parametric curve. That concludes the introduction of parametric equations. I'm sure most of you already know this. So let's move on to actually doing the question. Now first part, let me clear this. So first part, it says, using differentiation, show that curve C does not have a stationary point. So this first part here actually requires you to make use of differentiation to find the dy dx of the Cartesian curve. So to do that, first of all, we can find dx dt from the given parametric equation, right? 2 plus 2 cos t, differentiated with respect to t, will just give me negative 2 sine t. What about dy dt? It will give us secant square t. So to find dy dx, we will use chain rule here by creating this, right? dy dx multiplied by dx dt will give us dy dt. To find dy dx, all we need to do is bring this over to the right hand side, divided. dy dx will be dy dt divided by -2 sine t. So once we are here, if the stationary point exists, then dy dx would have a solution, right? Would have a solution if stationary point exists. So let's assume that it exists and let's try to find it. We should run into some problem because they want us to show that it doesn't exist. So doing this will run into some problem. So let's show the examiner that we will run into some problems here. dy dx equals to 0 would give us secant square t over -2 sine t equals to 0. So secant square t over 2 sine t equals to 0 will give us secant square t equals to 0, which is actually 1 over cosine square t equals to 0. What do you notice here? 1 divided by something gives you 0. That should ring some alarm because cosine square t. Now let's take a look at cosine t. Cosine t will only have values between -1 to 1, right? Because if you were to draw the cosine curve, it looks like that, right? You realize that the highest possible value is 1 and the lowest possible value for cosine t is -1, which makes cosine square t only lie between 0 to 1. There is no way this cosine square t, which falls between 0 to 1, when you take 1 over this particular value, it will never ever give you 0. This means that dy dx equals to 0 has no solutions, therefore no stationary point. So the second part, sketch C indicating clearly equation of the asymptote and coordinates of the x-intercept. You should indicate clearly the feature of the curve near the x-intercept. Okay, so what we do is we open up our GCE, make sure you go into parametric mode because we're keying in a parametric equation, right? So once we've done that, they'll ask you to key in the x equation of the parametric curve. So here is clearly 2 plus 2 cosine t. And for y, we will be putting tangent t. Okay, once we click graph, you should see sort of a mess because we need to go into window. Notice the t values. Remember just now that middleman analogy? What the calculator does is they generate out values from 0, from 0 all the way to 6.28, which is actually 2 pi. Now what happens is when you generate out so many values, you will get a lot of points, right? How many values you're generating depends on t-step. What t-step actually means is from one number, what is the next point I will generate? So they will jump by 0.13. Now if you put this as 1, what happens is the calculator will generate t equals to 0, a particular set of coordinates, t equals to 1 now because the step is 1. T equals to 1, then they will generate out another set of coordinates. A grand total of 6 coordinates. So you see the graph, once they do that on your graph, you will see 6 points. And what happens to the 6 point is the GC will just connect them with straight lines. So you will actually get a very jagged looking graph. Take a look. See? 1, 2, 3, 4, 5, 6 points. And then they just randomly join it up with straight lines. Starting from this point, I'll connect to when t equals to 1. So to improve the resolution of the graph, you actually have to decrease your t-step so that you're actually generating more points. So if you do like a 0.1, you should get a nicer looking graph, which is a bit curvier because there are more points. Now imagine you have this and this. They will just connect with a straight line, right? But if you have this, this, you actually form a nicer curve, right? So this is what happens when you decrease the t-step. You're generating more points. However, we are still generating too much because take a look at the t-min and t-max. We are generating too many points. We don't want to go all the way up to 2 pi. All we need is from 0 to pi over 2. Pi over 2. The number of points generated will be fewer, and you realize most of the curve you see just now will be gone. You're only left with this. It seems like you can just draw it like so, right? Looks the same, right? However, because the question says you should clearly indicate the feature of the curve near the x-intercept. So we should know something is going to be up here. So let's zoom in for a better view. Let's zoom in particularly on zoom. You see that it's actually here, and it makes a sort of a mini turn before turning down. So if you were to draw a smooth curve down like this, you'll be wrong. You should exaggerate it in your answer. It should look like, it should look like that. And this is the intercept. What the intercept is, you can calculate it. When you want to find the x-intercept, all you need to do is equate y equals to 0, right? Which is actually tangent t equals to 0, t equals to 0. Using this, t equals to 0, y will be 0. Find out the x value. 2 plus 2 cosine 0 would give you 2 plus 2 times 1, which gives you 4. So this, in Cartesian coordinates, this will be, 4, 0. Take a look at this. This sort of looks like there is some kind of asymptote, right? You should know because the question says so. It indicates clearly the equation of the asymptote. Vertical asymptotes happens when the y value is actually undefined, right? And if you were to go to the equation, for the y value to be undefined, you would need for y to be undefined, tangent t must be undefined. And when would that happen? Tangent pi over 2, right? Everybody knows that tangent 90 degrees is undefined. So tangent pi over 2 is undefined. So t must be equals to pi over 2. Same thing, we are using t equals to pi over 2 as the middleman. Find out what coordinate this generates you. You realize that y is undefined, and what is x? X equals to 2 plus 2 cosine pi over 2. Cosine pi over 2 is actually 0. So 2 plus 2 times 0 will give you 2. So therefore, x equals to 2 is the vertical asymptote. So if 4 is here, 2 is here, I should change my graph a bit. It should look more pleasant like this, right? 0, 2, 4. So once we've done this, this is the graph they want. So from part C onwards, the question would just be a differentiation question. You don't really need to refer to the graph anymore. Point P on C has parameter t equals to pi over 4. Okay, so using t equals to pi over 4 as the middleman, what coordinates does this give you? All you need to do is put this into your x coordinate to find x value. So 2 plus 2 cosine pi over 4. X equals to 2 plus 2 cosine pi over 4. Cosine pi over 4, it's actually root 2 over 2. This will give you 2 plus root 2. Find the corresponding y value. Y value is tangent t, which is tangent pi over 4. This gives you the value 1. So the coordinates would be 2 plus root 2, comma 1. This is point P. Question becomes find the equation at tangent at P. So just now we found that dy dx is actually how much? Secant square t over negative 2 sine t. Secant square t over negative 2 sine t. So dy dx at t equals to pi over 4 would be equals to secant square pi over 4 over negative 2 sine pi over 4. This is 1 over cosine square pi over 4 over negative 2 sine pi over 4. Sine pi over 4 gives you root 2 over 2, right? 1 over cosine pi over 4 gives you 1 over half. -2, root 2 over 2, 2 over -2, root 2 over 2, cancel, cancel. You will get -2 over root 2, which is just, after rationalizing, we will give you root 2 times root 2 gives you 2, so it cancels off with the 2, gives you negative root 2. This is the gradient of the tangent at P. So now all you need to do is gather all this information up, put it in the y equals to mx plus c form. So m is negative root 2. Your x value of the coordinates is 2 plus root 2. The y coordinates will be 1. So 1 equals to negative root 2, 2 plus root 2 plus c. Bring all this over, you get 1 plus 2 root 2 plus 2 equals to c. c is 2 root 2 plus 3. And then this would be your answer. So final part, find the Cartesian equation of the locus of the midpoint of this coordinate and -2, 0 as t varies. This might seem very convoluted at first. Sometimes the question will also say, find the equation of the, so sometimes they can say, find the equation of the curve traced by the midpoint of this and this. What this means is, as you vary t, this point changes, right? You have a fixed point, -2, 0. -2, 0, which is here. This point is fixed. What happens is you are changing this point. This point, as t moves, it becomes different points, right? If you were to take this particular one, I join them up, I find a midpoint, I will generate this red color dot, right? I can also take another t value, which generates this particular point, connect them, find the midpoint. You have this particular point. You can keep doing this. This one, connect them, find the midpoint. If we were to do this for every single t value, you will have every single corresponding red color dot point, right? And you can join the red color point up. It will form some kind of curve, right? The question will be asking you, find that particular curve's equation. This is what they're trying to say. Find the equation of the locus of the midpoint. Of course, what we do now is to create the coordinates of these red color points. Very simple. Just find the midpoint of this and this. So midpoint is just 2 plus 2 cos t plus -2 over 2, comma, tangent t plus 0 over 2. This should give you 2 minus 2, 0, 2 cos t over 2 just gives you cos t and tangent t over 2. Your job now is just to convert this into Cartesian as t varies. So your x coordinates would be cosine t, and your y coordinates would be tangent t over 2. The next step would be to make t the subject and squeeze this inside here. You will have a clean equation without the t anymore. However, it's rather difficult because you get something like this. T equals to cosine inverse x, right? And then y equals to tangent of cosine inverse x over 2. This doesn't really look nice. What you need to do actually is whenever you have x equals to cosine t, and then you have to make tangent t the subject, draw the triangle. So here, draw the right angle triangle. So here is the right angle triangle. Cosine t, so t is this particular angle. Cosine t is equals to x. We can also rewrite x as x over 1. Cosine is the ratio of adjacent over hypotenuse, right? So adjacent over hypotenuse, which leaves this length to be 1 minus x squared. Square root of 1 minus x squared. And to find tangent t would be rather easy now. Y would be, what's tangent t? Opposite over adjacent, right? So opposite over adjacent, which will give you root 1 minus x squared over 2x. Y equals to root 1 minus x squared over 2x would be the curve traced by these midpoints, these red color dots. And that concludes this question.